Okay, so definition 2 is not, we are no longer always going to put our circle in, our triangle in the unit circle, which is nice. I mean, putting it in here, we can have X, Y's, and R's, and we can do it just fine, right? Yeah. But life isn't in a unit circle, but we do have right triangles a lot in real life that you can make because the ground is usually horizontal, correct? And most structures that hold up anything are vertical, if they're doing any good job at it, right? So we have a right triangle, we have an angle, and we're going to use opposite. Do I need to write opposite, or is O enough?
That's fine.
Okay, opposite. What's A stand for? Adjacent, and H stands for hypotenuse. You have done this definition before, yes? In geometry.
How do you spell adjacent?
Adjacent is A, D, J. How about I just put it? A, D, J, A, C, E, N, T. Okay, so does anyone remember what sine of theta is?
Y over R.
It's y over r, so y would be opposite. So it's opposite over hypotenuse. So if you know sine, you automatically know what one? Reciprocal function.
Secant.
How about cosecant? S and a C. SC would be hypotenuse over opposite. So is this any different than what you just got done doing? Nope. Cosine is x, but to theta, x is the adjacent. So adjacent over hypotenuse. And then secant would be hypotenuse over adjacent. And tangent is y over r, so it would be...
You mean x over y?
No. Tangent is y over... Not y over x. Sorry. It's y in the numerator, not r. Y over x. So opposite over hypotenuse. Oh my gosh, I cannot talk. I keep trying to do it. Adjacent. And then I automatically then know cotangent, which is adjacent over opposite. So that's of theta, but could I also do it of beta?
Mm-hmm.
So when I do it of beta, the adjacent of theta becomes the opposite of beta, correct? Because opposite is over here. Yes? Okay, so pay attention. Is it always going to be the angle down here? Nope. It could be this angle also.
So if it's that angle, it's opposite, adjacent, hypotenuse?
Yep. Opposite is opposite. Adjacent helps make the angle. That's how you remember adjacent. It's touching it. It's making the beta. Okay, so triangle ABC is a right triangle. C is the 90-degree angle. And side A is 6. And side C is 10. So I probably should draw a what? A right triangle. Now that question that you needed to solve for the other side, I gave you a point for making a picture. Make your pictures. If you didn't make your picture, you didn't get that point. Okay, so triangle ABC. Does it matter where I put A and B? Angle A and B? No, but does it matter where I put C? Yes, because it says C is 90 degrees. Side A is 6. Side A is always opposite what? Angle A. Side A is opposite angle A. So 6. And side C is 10, so that is the Hypotenuse. And it says find the 6 trig functions. So I'm going to need, of A. So A is up here. So I'm going to have to do sine of A, cosine of A, tangent of A, and then the reciprocals. So in order to do sine, cosine, and tangent of A, I need to find what?
The adjacent.
The adjacent. How am I going to find the adjacent? Pythagorean theorem. Okay, so I'm going to have what? 100 squared minus 36.
The square root of 100 not 100 squared. That's a square root of 100 not 100 squared, right? It's 10 squared.
It's 10 squared.
I know, but you said 100 squared. Yeah.
Oh. So 100 minus 36 is 64. Square root of 64 is 8. Okay, guys, this is a 3, 4, 5 triangle. Does 10 reduce? If I divide by 2, do I get 5, 3, 4?
Yeah.
Yes. Okay, this is a 3, 4, 5 triangle. If you can reduce, you should always reduce. Should you remember 3, 4, 5 as a triangle? Yes. Only 3, 4, 5 if 5 is the what? Hypotenuse. So sine is opposite over hypotenuse. So opposite of A is 6, but we're going to put 6 over 10, so why don't I just use the 3, 4, 5? Wouldn't that make sense to use? Yeah. I reduce first, then I don't have to remember later. Okay, so 3/5. So if I know sine, I automatically know what?
Secant. Cosine. No, cosecant.
Cosecant. So it's hypotenuse over opposite. Write those, guys. So 5 over 3. Some of you don't know them yet. Cosine is adjacent over hypotenuse. So that would be 4 over 5. And if I know cosine, I know secant. So it would be hypotenuse over adjacent. So 5 over 4. Tangent is opposite over adjacent. So 3 over 4. And cotangent is adjacent over opposite. So 4 over 3. Did I go too fast for anyone? Okay, should these start going faster and faster and faster?
Yeah.
Okay. I don't think we need another example. Well, the only thing I wouldn't want to say, what if I ask you about theta? We're going to put theta here. What's the sine? Or I'll just put B. What is the sine of B?
8 over 10.
So 4 over 5?
Yeah.
Okay. What is the cosine of B?
6 over 5.
3 over 5?
6 over 10.
So 3 over 5. What is the tangent of B?
4 over 3.
4 over 3. What do you notice about those?
Nothing.
You don't notice about
Sine
any...
and cosine are just flipped.
The sine and cosine are just flipped. And what else?
Is that like, what are you talking about?
From A to B.
Oh, I was like, I thought you were talking about just B. I was like,
No, from A to B.
Well, they flipped around, but they're not the same. Like,
Well, isn't the
Sine
sine of B the same as the cosine of A?
Yeah.
And the cosine of B is the sine of A?
Yeah.
And the tangent of B is the cotangent of A?
Yeah.
Okay? So the sine is the cosine is the sine, the secant is the cosecant, The cosecant is the secant. What are you hearing? The sine is the cosine. The cosine is the sine. The secant is the cosecant. The tangent is the cos. The cos. What do I know about A and B? What is the relationship between A and B?
They're opposites.
Yes, they are opposite, but in every right triangle, this angle and this angle are what? They're what to each other? They have a
Complementary.
complementary. Is that what you said?
He said
No.
Oh, no.
coterminal.
Coterminal.
Coter.
No.
Sounds like
They're
they're
complementary. What does complementary mean?
They make 90.
They make 90. So when two angles are complementary, are the sine of one going to equal the cosine of the other?
Mhm.
Yes. The cosine of one is the sine of the other. So we have a definition of cofunctions.
Oh wait, are we supposed to write these?
It doesn't matter.
Okay.
I want to just show you. We will do it in a second. Cofunction. Bless you. So the cofunctions are sine and what?
Cosine.
Cosine. Secant
Cosecant.
and cosecant. Tangent and cotangent. Do you now know why sine goes with cosecant and secant goes with cosine? Because they're there. Okay, so when they are cofunctions, complementary angles bless you. Angles, we're going to put apostrophe. Trig values are equal. Bless you again. Does that make sense, what I'm saying?
Yeah.
Bless you.
Hey, you stop
What's
sneezing.
in your room, bro?
I don't know. It's not changed.
The dust. You haven't put in a little Scentsy for a long time.
I've got my peppermint air freshener.
I remember it.
That's not new though. It's been on there since we came back from break. Okay, so when I come here, I was trying to lead to it and it was too early when I was doing it. The sine of theta is equal to the what of beta?
Cosine.
The cosine is equal to the cosine of beta. The cosine of theta is equal to the sine of beta. Now, instead of OA and H, if I would have put, like, labeled this A, B, and C, and then I had lowercase a, lowercase b, and lowercase c, then you could see it that way too. The tangent of theta is equal to the what of beta? Cotangent. The secant of theta is equal to the what of beta? Secant.
You said secant is equal to what? So that's why I said cosecant.
I thought I said cosecant. The secant of theta is equal to the cosecant of beta. The cotangent of theta is equal to the tangent of beta. Okay. So in other words, down here, you could say, no, I'm not doing that. Said that. Okay, so examples of that. The sine of what is equal to the cosine of 30?
60?
60. Because you did 90 minus 30. Alex, the tangent of y is equal to the cotangent of what? Nope. How did I find 60?
90 minus 30.
And what do I have here? What angle do I have here?
Wow.
Y. So how would I find it?
90 minus
90 minus y. No secret. It's just minus the angle you're given. The secant of 75 is equal to the what?
15.
Cosecant of 15 degrees.
That's easy.
Yep.
Is this all we're doing right?
Not much more. 30, 60, 90, 45, 45, 90. You need to remember those. Your ratios. You guys remember your ratios?
Depends on
Hmm?
I'll probably remember if I see it.
Really?
Yeah, I'm just like,
Square root of 2, square root of 2.
oh, yeah,
That stuff.
yeah.
You scared me a minute. So what are my ratios for 30, 60, 90?
1.
1.
Square root of 3. X times square root of 3. No. Isn't it 2x?
Yeah.
2. Okay. And then 45?
Square root of 3. No, square root of 2. Square root of 2. 2.
Okay. And again, you could also use 1, 1, and then square root of 2, yes?
Yeah, but I don't want
I don't like it either because this keeps my 2's both on my hypotenuse. So if I want the sine of 60, and again, if I'm writing it quick on my paper, I'm only doing this. See how quick that is?
Yeah.
And then I don't have to worry about my brain not liking that that's not a 45, 45, 90 triangle. Okay? Sine is what over what?
Y over what?
Or opposite adjacent hypotenuse. Opposite over hypotenuse. So what's opposite of 60?
30.
What's opposite of 60?
Square root of 3.
Square root of 3. Hypotenuse is
2.
2. So if square root of 3 is opposite, that means adjacent is what?
1.
1. Because 2 is always the hypotenuse. The cosine of 45. So cosine is what over what?
Adjacent over
So adjacent to 45 is,
square root of 2.
so adjacent hypotenuse, so square root of 2 over
2.
2. Okay, they will say use table whatever to do this. Don't use table whatever to do this. Use what?
Triangles?
Triangles. Can you check it on your circle to make sure you're right? Because that's why we made it yesterday. Okay, so then it's going to say use exact values. Okay, these are exact values, guys. 30, 60, 90, 45, 45, 90, 180, 0, 90, 180, 270, and so the other thing we need is this. And what are my points? What's this point? 1, 0. What's this point?
0, 1.
0, 1. What's this point?
Negative 1, 0.
Negative 1, 0. And 270.
0, negative 1.
Okay, so in here we're going to use x and y, but here we're going to use opposite, adjacent, hypotenuse. Because there is no triangle on this circle, is there? Like on the coordinate, on the quadrantal angles? No. Okay, so use exact values. So this and this you need to be looking at. Okay? To solve, cosine squared of 30 degrees plus sine squared of 30 degrees. So first of all, you know cosine squared plus sine squared better equal what?
1.
1. Okay? It better equal 1. So it better. Because we know that. Pythagorean identity, yes? So we know the answer should be 1, so let's make it equal 1. So this cosine squared of 30 really means cosine of 30 and then what?
Times it.
Then square it? But we're not going to write it like that every time. That's gross, isn't it? Okay, so what is the cosine of 30? Cosine is what over what?
X over R.
A over H.
A over H?
Same thing.
Yep. Okay, so adjacent over hypotenuse. So looking at your, what's adjacent to 30?
1.
60.
Nope.
Oh, square root
Oh,
of
my bad.
Sides. Sides. Square root of 3. What's the hypotenuse?
2.
2. And we're going to
Square root.
square it. Plus the sine of 30. So that's opposite. So what's opposite of 30? 1 over hypotenuse. 2. And we're going to square it. Well, the square root of 3 squared is
3.
over 4 plus
1 over 4.
1 over 4. So I'm pretty sure that equals 1 over 1. Okay, it said show that. Is that a proof? Yes. Okay, so most of you forgot the box on your proof. Most of you forgot that you work down and show every step. Did I cross things off and do a bunch of crap to make so I can't read it? No, don't do it. Okay, we're going to prove it again that cosine squared of 45 degrees plus sine squared of 45 degrees equals what again? 1? So, what's the cosine of 45?
Square root of 2.
Over
2.
Okay.
plus, well, the sine of 45 is also
Same thing.
square root of 2 over 2. So, square it, we get what?
2 over 4 and 2 over 4.
2 over 4 and 2 over 4, or 1/2 plus 1/2, which is
1.
1. Okay. Let x equal 30 degrees, y equal 45 degrees. In each of the expressions follow, simplify the expression as much as possible. So 2 sine of x. And the book doesn't put parentheses around that x. I would encourage you to put parentheses around what you're taking the sine of. It helps your brain. So what do you think we do?
Plug 30 in for X.
Plug 30 in for x. So 2 sine of 30 degrees. Okay, so sine is opposite. What's opposite of 30?
Square root of 3.
Nope.
1.
1 over hypotenuse,
2.
2. So the answer is 1. Do you see how important it is going to be for you guys to remember those? Every day we are going to use those from now until the end of the semester. So sine of 2y is how the book reads it. Where should I put my parentheses? Around the 2 and the y. Okay. So what am I going to do there? Plug y in. So I have sine of 2 times 45. So the sine of 90. Okay, so sine of 90, we're using this point up here, which was 0, 1.
Yep.
And is sine y, x or y?
Y.
Y, and what's the y?
1.
So equals 1. Last one, we have 4 sine of 3x minus 90. So I'm going to plug in what? X, which is 30. So 3 times 30 is 90, and 90 minus 90 is, so I have 4 sine of 0. Okay, well that's this point over here, correct? Which was 0, which is not 0, which is what? 1, 0. Sine is which one, x or y? Y. So the sine of 0 is 0, so my answer is 0. That's what you're doing today.